All right. Thank you, Robot. Good evening. My name is Todd. I thank you for coming. Tonight we're going to just talk about some algorithms. We're going to talk about just prepping for interviews, and if you get asked to do whiteboard stuff, like what to do, and just general questions about like what's the job or what some roles are, and just have like open discussion. So it's a small group tonight, and I like that because we can all just kind of talk. So if you have a question, feel free to interrupt. It's okay. We can just make this very communal and social. But if we do get a flood of people in, we may change it up. So yeah. So there's three. Oh, did I change that? No, change that back. All right, so we're just going to cover three sections. Like I said, just the job. We're going to talk about what it is to be a software engineer in the software community. We'll talk about some like core, more concrete things that I think are like really important as a software engineer just to understand, because they're foundational, and that's algorithms, data structures. And we'll just do a quick fly through over that. And the last thing is just interview tips, right? All right, so just to open up conversations, there's sort of these like things that everyone kind of thinks about when you're coming in to become an engineer. It's like, oh, I'm gonna like make more money, I'm gonna have more free time, like I got better benefits, like the world is my oyster as a software engineer. And then you start doing the job, and like what you realize is that most of the time you're writing just a bunch of tests, and you got more money, but you got more problems, like because the tax man cometh. You write a lot of okay code, but like something drives you to like always want to do better, right? There's always this thing that's like, I know like next time I'll have a better understanding how to do it, right? And I've been doing this stuff for my whole life, and I'm 42, and I still feel like that. So I'm just gonna tell you, like, it's okay. Like, I'm always learning, and I always will be, and it's the thing that I actually like about it, is that this industry is always changing and adding new layers on top of like the good parts. So it's just part of swimming, really. Let's see. And just to say, like, add on that, it's hard to be an engineer. Like, you are basically expected to listen to someone's problem and then make something new that they're gonna like, without maybe not even experiencing their problem, right? And so it's an empathetic endeavor in a lot of ways. And you can think of, the best way I think of it is to think of it in terms of like you're providing a service, and because you have a skill that is very valuable, right? And the better customer service you provide, the better engineer you'll become, right? You can be a terrible coder and great at customer service, and you'll do okay, right? But you better learn how to code and catch up your skills, right? Like, obviously, like customer service will only get you so far. You still have to produce a working product, right? So what's important is, regardless of like what role you take in this industry, I think, even if you're a product manager, just being logical and reasonable, super important. People may seem annoyed or frustrated if like you're off topic or maybe adding noise and stuff like that. And like what that really means is that, that's just good, honest feedback. And like building products is hard, and being able to accept feedback and understand that everyone is just trying to move forward the best way they can, and cut out noise and laser focused on like the things that you're trying to achieve, right? So that's like really kind of like problem defining, and that's what that bullet point's about here. Last thing is like somewhat important, because it's not terribly important. It's important, I think, when you go to interviews, especially like I've been in many interviews where I sit down with like the senior engineer or whatever, and they open up their tools and they're like, okay, like this is like what I'm working on. What do you think you might do to like help fix it, right? It's super super nervous at times, right, to have that experience. But you know, some roles require that, and that's okay. So having the familiarity with like your IDEs or text editors or whatever you're using, you know, popular tools of the day, is less important. You can pick a lot of stuff up on the job, but coming into the interview, I think it's important to be able to identify them and be able to like work with them if somebody asks you what they are, how you're doing it. So like I said, it's a small group tonight, and I just kind of wanted to open the floor, and maybe we'll just you can help me, Conrad, and just call out someone and just kind of tell me your story and like what you're looking to do, or you know, where you're at in your journey. And
I'll start. I'll get the ball rolling just to introduce myself. I'm sure you all have seen me in the general channel as Hall of Answer, but I currently work as a senior technical PM at Unity Technologies. We make a lot of if you've played a game on your cell phone, it either runs on Unity or Epic Unreal. So I work on the artificial intelligence team over there. Before that, I was in the Army. Spent some time in the infantry, realized I was more of a geek than a grunt pretty quickly. Ended up heading over to the Signal Corps, got out and made my way into tech industry. And everything that Todd said so far is like spot on regarding there's the kind of what, you know, if you watch HBO Silicon Valley or something, what they sell you about being a software engineer. And then there's like the reality of being a software engineer. And Todd's talking a lot about what the reality of being a software engineer is. I see Peter is grinning, so I'm going to tag Peter.
Hey, thanks. What's up, everybody? I'm Peter Bruner. I'm a software developer at Deloitte. Bootcamp educated in Java Spring, and I've been working in C# ever since. And
you like XML files?
Not particularly. I don't know who does, but anyway, so I'm here just for general support, but also you know, I'm going through a job search thing myself, so I'm trying to get my next job. And so for me, it's kind of a leap where you know, I was hired without like any kind of technical interview, right? Like they just picked me up basically because I said I could code, and maybe because I had a security clearance. So I'm trying to get that next role, whatever it is, compete in the market, and hopefully tackle the coding interview circuit, because that's at least internally, leak coding, all that's kicking my butt.
Okay.
Over to somebody else.
Just me, right? I don't see anyone else on the cameras. I'm Jay. I'm in the Coast Guard right now. I'm down to single-digit work days, so I'm super hyped. I'm very happy, you know. We got holiday routine coming up, which I don't know if that's a thing on the civilian side, but got to enjoy it while I have it. And I'm learning JavaScript right now, just kind of self-taught on that. And I'm signed up for Operation Level Up through Galvanize. So that starts in January. I was also talking to Skill Distiller out of Colorado. They start in February. I'm debating them. And I also thinking about putting in some applications for like a local program, a local company called Geographic Solutions, and they do like web scraping, and they turn that into, they sell that data to states for their unemployment websites. They kind of run Employ Florida and like Employ Texas, and just like a state-run job board. They kind of do the software for that. And they're like, hey, we'll take entry-level people. So hopefully I get an interview with them. And like, that's my top goal, is to get a job. If that doesn't work out, go to a boot camp. If that doesn't work out, I don't know, drive a truck or something.
I think you'll be successful.
Thanks. Oh, we got someone else popping up in here.
Yeah.
Oh, we got a lot more. Never mind. Who's next?
Yeah.
You guys see?
There we go.
I can hear you, man.
Yeah. Hey. Yeah. I'm still at work right now, but yeah, I just wanted to introduce myself real quick. I'm Andrew. I'm currently still in the Army, and I have around 7 or 8 months before I ETS. But what I'm what I'm doing with my last couple months is I already got accepted into Code Platoon in January, so I'll be doing that for my skill bridge. And currently, in the meantime, I'm just trying to teach myself like web development through the Odin project. And my main goal is like to really just give myself a marketable skill set, because right now I'm an engineer officer, which is not like that technical of a skill set, and I just want to like kind of learn something and like kind of move towards tech is what I want to do right now.
Okay. Kevin? Oh, we have two Kevins. How about Justin?
Some folks might have mic issues.
Hey, I'm tuned in on my phone. I don't know how good my connection is, but I am a junior engineer working for a company called ShopRunner that is owned by FedEx. And I am a Code Platoon graduate also. I heard, I think it was Andrew saying that he's going to go to Code Platoon, so really good program. I went through Skill Bridge as well. I got out of the Navy in April of this year, and I am just trying to get better at algorithms.
Okay. Anthony?
Hello?
Hi.
Hi, sorry. Okay, so I just saw this link off of the Slack channel and wanted to see if I could pop in. I'm currently a student at University of Maryland Global Campus. I'm in my senior year. I have 6 classes to go. I'm currently in data structures and algorithms, banging my head against a wall, learning binary tree structure and syntax. And then I have finals next week, going over graphs. And I hope this can help.
We got you going hard mode right away, huh?
Yeah. What was it? Last week, or I just submitted my 3rd project yesterday on binary tree structures and doing recursion, and that was my first time doing recursion coding. Waiting for a grade back. I think I did okay. I was able to make things work how they wanted to, and I think the thing that I have trouble with is going from when I read a text, I can understand the logic, but applying that to syntax within a language, especially Java, that's been the difficult part.
Once you kind of see the forest for the trees, you sort of realize syntax is like sugar. Yeah. And then you get to the point in your career you understand how to like write like domain driven languages, for example, right? Because you'll be at bigger orgs that, they don't want somebody to write yet another, history service, right? They just want you to use the history service they already wrote. So they'll write languages that support their model and understanding of how the business works, right? Anyway, I bring that up just because you were talking about syntax, and I think like what's nice about languages is what they do under the hood, and the syntax is like great and it's like helps developer productivity, but once you start jumping between languages, you sort of see the same patterns that we're going to talk about tonight, and you can use them in any language.
Right. So, for example, like when we were covering basic binary tree structure, a binary tree that has a parent, that has a left child, well, in a binary tree, parent, and then a left child, and then a right child, and I would assume that's the case across Java, Python, etc. In the same way that object-oriented programming is the same, where you have an object and then instances of classes, and then that's the same as well. Is that correct?
Yeah, or just even simpler, like where you're talking about in a binary tree is like sort of like key value pairs in a way, right? You could think of it that, like you have an object and then there could be a key and a value, right? And maybe you want to graph things that way because like sometimes you only care about the keys, sometimes you only care about the values, sometimes you need both, and then you want the object, right? Like that's another way to think of it. Getting ahead of ourselves. Let's dive into it. Okay, so data structure categories, right? You have three basic categories. Creational, and this is just like, hey, I need an object, and I need an empty object, or I need some kind of type of object. We'll cover these. Structural, this is like, I want to represent something that will become an object, right? Like maybe I need to attach some behavior or some function or key or something like that to it. These are, and then finally behavioral, this is like defining what things do, right? Like click handlers, or there's some other things like that. So let's talk creational. Okay, creational is your most commonly like used things. Like these are your get it done fast, but usually not quick performers, right? So you could do a factory method, right? That's like where you say, hey, like every time I call this, I want a new thing of that. Abstract, this is saying, create, like I want you to make a thing that I'm going to call what I want to call it, and you're going to give me that, right? So abstract, right? Builder, this is saying like, hey, I want to have like a schema, and I want to build an entity from that schema. Is that if anybody's confused on that term, please let me know. So like entity schema example, right? Like you want to say like maybe I have a car and I want to have a car schema that says this is what a car looks like if I was going to define one, right? And then the entity can be your class definition of what a car model would become, right? That's a builder. Prototype, you see this all over JavaScript. Fully initialized instance used for copying or cloning, right? And then singleton is sort of the opposite of that. It's when you have a class that only has one, it's global in a way, right? Like there's only one instance of it, and you can't make another one, and it'll complain if you try. Any questions on creational data structures here? We'll see some examples too. Okay, we'll get to this. Structural. So structural, like I said, this is like how you want things to kind of get built or handled, right? So adapter, that's the most common class that you'll find. That's like when you say like, hey, ORMs do this with like databases a lot, right? Like you have like Hibernate. I heard somebody was talking about Spring. So you have Hibernate as your data access layer, right? And then Hibernate then can talk to like MySQL, or it can talk to SQLite, or it can talk to Oracle, and it does that using database adapters, right? And that's exactly what these things are, is classes that take one API and translate it from another API and makes it consistent. Bridge, okay, separates the interface from the implementation so they can vary, the two can vary independently. This is like when like you keep extending from one thing or an interface, and then eventually it stops working the way you'd hoped. So you want to be able to bridge between those various things and create a new concrete interface. Let's see here. As far as like I had some heavy JavaScript calls out, so we'll talk about some of these more important ones. Decorator, that's like where you want to like you get a method that you want to attach a function into, right? So you want to like a good example, you'll see it like again in like ORMs, where you'll have like a method it'll be like convert to JSON, and then you could say like on top of it, you could put like an annotation that says like use JSON parser or whatever, right? And then the code will know when it's compiled that when that's called to like use this adapter for JSON instead of like the default one, for example. Let's see here. Go back to, sorry. Facade, okay. So facade, that's a high class that hides the complexity of a subsystem, right? So you'll see this a lot. Like I like to call these like roll-ups, and that's like where the implementation of like the like sort of domain language stuff is like where you would have like a facade, right? So you could have all this like complex subclasses and all this stuff moving around underneath it, but then all like the sort of orchestration stuff happens in one simple class that when you read it, it really clearly explains the logic that you intended for, you know, it to implement, right? So like a good example of this like might be like you want to like assemble a customer's invoice, right? And so you could write like a facade class that like very logically explains, you know, grabbing the fields that you need for that and where they go, right? But the underneath, like you don't need to like put all those methods of like here's a PDF thing and here's this like, you know, all this other complexity. Moving on, flyweight. This is a not used to this moving. Flyweight fine grained instance for efficient shadow information is contained elsewhere. So this is like a good way. Another way this I see this used a lot is like where like you are using a lot of messaging kind of things going on, and you want to use something to like take messages out of like the queues or things like that. And that way, like you still have it around and it's like kind of cached. You use a flyweight to do that, but then, you know, once the queues are like, you know, back to resilience, you can, you know, bring that stuff back in. Also, last one on this one, proxies. Proxies are a lot of fun because it's you can take an object and then you can send it through a proxy and it creates a representation of like it's like saying like on behalf of this class, right? Is another way to represent that. Any questions on structural data structures?
Hey, also, since we're recording this, we're going to send out the video to everybody if you need to like go back and dig deep and dive in. And if you have follow-up questions after this, you can ask questions in the help channel after this presentation in case there's stuff that is clear as mud, you know what I mean?
Mm-hmm. Yeah, it's a complex topic. So if, you know, when we're flying over it like quite a bit really quickly. So yeah, good call. Last one is behavioral. So these are like where you want like more of like your business logic things to live, right? The things that you need the app to like, you know, mutate data or, you know, go get stuff from other systems and things like that. Or you know, just simple like, hey, when this, you know, when A happens, do B, or when A happens, like notify some system, like things like that. And that's what these are speaking to here. So observer is probably the most common one. That's like, you know, just, hey, like go watch for this file change or watch for this variable to update, things like that. And then state, that gets used with observer quite a bit because that's the thing that you're observing, right? Is the state. And then there's some other ones inside of here. You might hear, like, if you're in the React community, it's pretty popular, is like provider consumer. And provider consumer is built on top of these, where you are creating like a context that you have state with, and you pass that down to anything that's within that context. And that's what the provider holds. All that chain of responsibility right here. Last thing we'll talk about on this one is visitor pattern. That's like where you are, you may have an object that you want to send through this pipeline, and then once it visits a certain class, you append some additional method to it, or change it, like proxy it or things like that. Okay. What is programming basically? So a lot of that sounds really complex and it really is, but I promise you, like knowing all of those patterns and the categories of them will get you very far in programming regardless of the language. You can take all those patterns and assemble pretty much anything you could dream of. True. So when it all comes down to it, we kind of started out, we were talking about binary search trees, and like I said, it's really just all key value pairs most of the time is what we end up dealing with, and questioning like, is things by value or by reference, just understanding like logically, and we started out knowing what is your app doing, can you like step through it and debug it, and what are the behaviors you intend to do, like can you do like upfront design a little bit, and go through like kind of those like whiteboard steps when I get into next. Last thing I wanted to just point out is, if you haven't heard this already, is solid principles. This is like critical, I think, to being really good at programming, is knowing these types of things. So single responsibility principle, that's don't make like classes more complicated than they need to be, like keep them very focused on the thing that they need to do, right? And when you find that they're getting too fat or whatever, like reevaluate, maybe extracting that and reorganizing the code to be more efficient. Open close principle, that means open for close for modification, open for, what's the other one? Blanking out right now. Open for extension, that's right. God. Open for extension, close for modification. So that means like, don't just go in and start writing in your code and other people's methods and stuff that, we're working. If there's truly a bug in them, see if you can extend those methods first and maybe override them, move them out of your way, but keep the original stuff there. Like, don't go adding more bugs to fix the bug that you're currently assigned to. Sorry, I had to drink some water. The Scott substitution principle. So this is, let's see. Okay. Right. I'm glad I'm looking this up. So if we were to substitute a superclass object reference with an object of any of its subclasses, the program should not break, right? So what this is saying is that, like, if you were to make a class and then have other things extend from it, you want to be able to ensure that if something in that chain were to change, that the program would still be able to operate without the superclass involved. Makes sense? So it's sort of like if the parents died, the kids can still operate.
That was dark, but okay.
It was dark, but yeah, okay. What's a better way to say it? Like if
No, I think it's fine. You got the right audience for that.
sorry, military coming out on me.
Kevin has a question here, whether anybody's kind of seen some of these things surface in their interviews.
Yeah, good question. Open it to the floor. No.
I would say the last piece about testing, is absolutely something that it's not, let me put it this way. It's not a question that will come up. It's more like if they're asking you that question, you forgot to do it. Or you forgot to like kind of mention the context of it. So testing is something you want to be proactive about bringing up kind of on your own. You know what I mean?
Right. Yeah, I mean, like programming, I say this all the time, programming is about algebra in a lot of ways. Like you're the person who's designing that 0 = 0 when it's all done, right? You know, like the testing is the left side of the equation and the application is the right side. And, you know, good solid testing means a good fitness of your application. So yeah, very important. I've been in tons of shops, and I'm currently a victim of a lack of testing in my own role right now. And you know, correcting it is you know, it's important. It has to be done. I can't value testing enough. And like if you find yourself at an org that doesn't value it for whatever reasons, like there are reasons, and they are valid. Like I had a stint where I worked at StubHub Labs, and I was literally building mobile apps on the fly with people testing new features, and that was all throwaway code. I wasn't expecting any of that to go to production, right? That's a good time to not do testing. But other times, you know, if you're going to go to production with it, I think it's critical. Okay, let's talk about whiteboards. Okay, so very simple, like there's a couple of big strategies, but I think this is like proven tried and true is, and even not on a whiteboard, like this is just something that practice as a good habit as an engineer. The first thing is just restate problems. Like make sure that you're able to communicate back to your customer that you understand what they're saying to you, right? And you don't have to say it verbatim back to them. In fact, I would discourage that. I would say, you know, try to restate it in a way that, you know, maybe even encourages some of their own new ideas, right? And, you know, not to take them down a rabbit hole, but, you know, stay on point. You know, and then the next thing is to like kind of break it all down, right? Like one of the methods that I learned in the military is called half split bracketing, and maybe there's a better term for it out there, but I never learned one. And that's where you look at a problem and you try to just divide it in halves, and you keep working the problem in those halves and testing left side and right side until, you know, you walk the whole tree and, you know, you get to the smallest, you know, workable part. In programming, it's a lot about just like, what are my inputs? What are my outputs? You know, what, you know, very basic, like what kind of orchestration do I think I'm going to need, right, to get this done. Once you kind of have some understanding of the parts, you're like, okay, like I think I've seen that in Snapchat, or I've seen something like that over on GitHub, or, you know, that was on Stack Overflow. You know, talk about that a little bit. And then, you know, right as you're doing this, just kind of like marker all this stuff out, right? And then, you know, finally, like once you kind of have a good understanding of it, just do like, before you get to the pseudocode part, I would just go through and just say with the problem one more time and just, you know, review with the client. Because one of the things that I find a lot of times is that once you start going through this part, this problem isn't the same problem anymore. And so it's important to get those feedback loops going, right? As you go through this exercise, you know, and coding interviews, like especially, right? Because they've done this problem like 50 other times before you even got there, right? It's new to you, but it's not new to them necessarily. And one of the other things you kind of got to realize is that, like, you know, chances are they found something from an article they read a long time ago that works, and then they're just applying that, you know, same strategy every time they go to each interview, right? So if you can do little skunk works and figure out what's going on in the interview too through networking, then do that also. Last thing is, so move on, write some pseudocode. So once you kind of understand what they're really asking you to do, then just like kind of write out some pseudocode. Don't worry about syntax at all. If you can just logic out the steps at this point of like all the things that you might have to like do, then do that, right? So, put a concrete example on this, like a whiteboard question might be to like do like a API for an elevator, for example, right? So then they're, and then they start talking about the edge cases. It's like, well, they want the elevators to return the middle, but it's 21 floors, so there's not really a middle. All those kinds of things. And then there's not a 13th floor, so there's actually, and they throw all these like things all these lumps at you during the interview. And the reason for that isn't really to like, see if you're technically good. It's to see like, are you adept at handling change, right? And also just to like walk through the problem, right? Because like one of the things about being an engineer, like I said at the beginning, is that like you're coming up with a new process for something, right? And you can't expect your customer to know what that is, right? You have to pull it out of them and ask just tons of questions. So write some pseudocode, and then next thing you do, like we were talking about testing, you can just do that with your pseudocode, right? And so at some point on the whiteboard, you get to where you may have like some kind of, some sort of classes, maybe some, or just some simple objects like creation objects on the board to define, the elevator and maybe the, the buttons or whatever, right? Then test that process, right? Like run an elevator through the process on the board, and like a lot of places will have those little cool magnetic markers at the top of the whiteboard, or if like pro tip, throw some in your bag, have just some magnetic like things when you go to your interview, because they're nice. I've been to tons of interviews too, like they can't even get good markers, and so having some just like in a bag ready for you to like pull out, like sometimes they appreciate that. So test your process. Last thing, demonstrate command presence and confidence. And really this, like one of the strategies for this, I think, like it's really easy for the military, I think a lot of times for us to do that, assuming what we've been through. But also just as you go through and ask these questions, like that, those are your opportunities to demonstrate some confidence over understanding it. Like, like I was saying, like being good at customer service, like can get you pretty far through the interview process, right? Because you're doing that sort of like upfront work that like engineers, I think, would kind of expect when you're new to a problem, right? Is to come in, ask a bunch of questions, like kind of figure out like a draft solution, right? And that's once you get to this part, right? Like you probably are feeling pretty good about it, and you're also putting off that energy to the interviewer that you're comfortable being in that position, right? And I think that's what a lot of folks who do have like imposter syndrome or just nervousness in the interviews, like don't realize is that like they may just simply be getting passed over just because people are like, oh, I don't know, they weren't as confident as the other person. So, but they may be like technically better. We just don't know.
Good phrase there, Todd, which is like command presence. And everything that's like this is an area where as veterans you can have a little bit of an advantage. Anybody who's been on a board, well, hopefully you haven't had to deal with too much of that shit, but the point is like a lot of folks go there and they'll like get totally mute, or like they'll freeze when they're having to do these whiteboard engagements, and confidence counts for a lot, even if your code sucks.
Yeah, it's okay to ask for help on this job. It really is. Obviously, like you can take that too far. I've seen it taken too far, but
yeah, that's also true. That's a conversation for another time. Maybe.
That's a different topic, but this is about getting the job. Knowing your senior developer will be the next OC of it. Last thing is discuss what can be improved at the end. Like it's even just like kind of the reverse psychology of this, like here's the cool thing about being the interviewer that a lot of people don't realize is that like you have a lot of power over the conversation, right? Like and this is kind of like going to this command presence thing, is that like if you can kind of help the interviewee like through your journey and demonstrating to them like your skill set, right, then you'll find that you're the one kind of like showing them the gates to hiring you, right? And so like discussing what can be improved at the end, right? Like to get to my point is that you can almost like think about like you could set your own little traps as you go through the process and just make your mental note that later, like that's the thing that you're going to talk about improving, right? And maybe they'll even see that flaw on the board right away as you go through it, but that's okay, right? Because like part of being a good engineer truly is that like you don't go in full boat on the first draft. Like you really do have to make the smallest thing possible that works, right? Because a lot of times that is the thing that makes the customer most happy, right? Is to have it in their hands right away versus, you know, waiting 6 months for a big complex like system that, you know, maybe improves performance by half of a second, but like doesn't make an impact in their life, right?
What was the point about magnetic things? I get the point about the markers, but the magnetic things, is that like setting breakpoints on the board or something like that? Like, what was the idea there?
Yeah, so you can go to like Staples or Office Max or whatever store like that, and they have just like they're like round circles with they're just with magnets on the back, and you can stick them on the board, and they're just really useful for like, you know, like I said, like if you want to just use it for like categorization, like, you know, like I said, through these software patterns, if you're demonstrating to them like, hey, I understand these are my creational patterns, these are my behavioral patterns, right? You know, as you're going through the sort of the pseudocode things. Also just for like marking, you know, the different sort of steps, right? Like you could say like red column is like describing the problem and blue column is, you know, my pseudocode or whatever, right?
Okay, cool, thanks.
Yeah, it's like this is my, I guess this is my takeaway about whiteboards. It's amazing how many orgs I've been at that like don't know how to effectively just use a whiteboard itself. Like they spend thousands of dollars on these like whole wall whiteboards, you know, and they got like the super nice 99 things on them, but then like no one's ever taught like what they're for, and then they don't use them, and I always was fascinated by that. So there's all these like great little things about like whiteboards that you can get to just like really, you know, jazz them up, right? Like I mean, just sticky notes, for example, and being able to like, you know, they have the things like where you can stick the like scanners on the whiteboards and then have them feed right into Office 365. You know, stuff like that. So like I've been on a org where we weren't using Jira or anything. We would just use sticky notes on the whiteboard, and then we would just scan them all in if we ever had to like communicate it to somebody who, you know, didn't like that process.
Cool, thanks.
Yeah.
Also plug for checking the chat. Looks like Anthony has a question there.
Oh, sure. I don't have the chat, so feel free.
I can read that for you. So whiteboarding strategy is from Anthony. At what point or at all in whiteboarding process do you want to consider time/space optimization and complexity, onset or after the basic solution, or does it kind of depend?
Yeah, you don't want any complexity. I think part of the exercise is demonstrating that you can avoid complexity, you know? And like one of the things that I think early on in my career that I thought was making me a senior developer was being able to like roll out like all this complex stuff really fast. And it turned out like oftentimes what I did is flooded all my team with like a bunch of stuff they weren't ready to understand yet, or, you know, or I just created like a whole backlog of new bugs that we weren't ready to do, right? And so really like that, you know, you're going to these interviews, maybe they give you 30 to 45 minutes to whiteboard out like an elevator. you're not going to cover all the complexity of the perfect elevator, right? Don't try to, but do get an elevator from the first floor to the second floor, right? Does that help?
Hi. So a little bit. I think in regards to the question was like, so in some examples I've seen from people in their interview prep, usually, or like questions from Leak Code will be, okay, I want you to design an algorithm that needs to solve this problem within O of N complexity, and then go. But outside of just doing an interview, do you say when you go to solve a problem or approach a problem that, okay, the best case will be, I want to initially solve this at O of N, but I could probably maybe only get a O log of N solution out. It's like, do you want to just put whatever you can on the board, or do you want to tell the interviewer, it's like, okay, do you want to display your worst case, or do you want to really try to struggle with coming up with their O of N solution?
I mean, best case scenario is you get that question, like a concrete one like that, and you know the answer because you were studying those questions, right? What I would say though, like if you get something that concrete, then like they probably do know the answer already, right? And that's okay. You may not know the answer either. And the best thing you can do is like, don't pre-optimize, right? Like you have this opportunity at the end to recognize that what you wrote isn't, that requirement, but that's okay because you literally crank this out in an hour on a whiteboard. It doesn't compile on whiteboards, right? It's okay. So just do the best you can, like, and crank that out. Like, if that is the requirement that they have for that job too, like, think about that. Like I've had jobs where like they're just like, hey, we just want somebody to come in and do some like React Native and jQuery, and they're like, oh, by the way, can you implement binary search tree without any standard libraries? I'm like, for HTML developer, I don't know that, And so just remember that, like, I think I said this in the Slack channel earlier, that, sometimes you just meet engineers that become managers that have just crazy ticks about things, and that's like their hang up, and, maybe it's just a lack of not what is really important, right? Like, if you're, I think like just like this, if you've been doing this for a long time, like, you know what failure looks like. Like, you live in failure like all the time, because this is a life where you get excited about error messages, because the lack of an error message means like days of debugging, right? And so it's weird to people who don't do that, right? Because we get an error message and like, everyone perks up in Scrum. We're like, we got a nugget, right?
Okay, thank you very much. I'm sorry if I got off track with it.
Oh yeah, it's okay. It's all conversation. So. Yeah, I just truth is that like I think with whiteboards, like you can kind of just like shake someone out and just see like, can they logic through it. And I like personally interviewing and using whiteboards, like that's always been the strategy I've taken. Like I want to see like, can they get to this part, and like just show me that they can logic their way through it, right? Like if I have a requirement that it's in one or whatever, then I'm just stretching to see like maybe they already know, maybe they know how to write a Fibonacci sequence, in JavaScript or whatever, right? Maybe they know that. Maybe they don't. That's okay. It doesn't necessarily mean that you're like a better engineer than someone else. Like I think if you're good at research and you're good at customer service, then you can be a really great engineer. All right. Go ahead.
Sorry, my AirPods died or something on me, so my audio got all goofy for a sec. Kind of piggybacking on maybe some of the preconceived notions of interview, algo prep, and some of the things Anthony was saying. Are most interview questions not data structures and algorithms based, like very specifically leak code style questions? Is it more OOP, developing classes and functionality, your elevator example?
I don't think so personally, but maybe I'm wrong on this. What are you seeing, like, Conrad? Do you see a lot of like straight out comp sci questions out of the gate, or?
Depends what kind of company that you're going for. I think that there are companies where the technical recruiters and then the hiring managers, let me be direct. Most hiring managers in tech have not been trained how to hire. They hire people based on how they were hired. And what that means is if you get the whiteboarding hazing type ritual from them, that means that was the way that they were hired. If you end up getting like more stuff that's kind of like the typical cracking the coding interview, like boilerplate type questions, it's because it was how they were interviewed. You can tell a lot by these organizations by the kind of questions that they ask and how they interview. The best organizations, from my perspective, Todd, let me know what you think, is like, are the ones where it's very clear that the problems that they're asking you to solve are problems that that business has or that product has. The ones where you got to watch out is like, once again, like the binary tree example, it's like, why do you need me to do that when I would never do that? When I would never do that given the scope of the work. That's when, those are all indicators of kind of like what that engineering team is like.
Yeah, the best engineering teams have like laser focus on the business's problems and solving them, and not, how tiny code, you can make hiding and showing a button. Like, you know what I mean? Like the thing about like this too, like you're also taking the reason, in my view, that software developers deserve the salaries we get is like, like this is complicated stuff, like plain and simple, it's valuable stuff. And
It's
the things
hard.
that we, yeah. Oh, and the
That's
things
all.
that we, okay. And the things that we create can 10x the value of the company, right? And so just keep that in mind, right? Like there's great power in software. And so, go work at a company that's going to value solving problems, because it's the thing that I think engineers like doing, right? Like no one goes to the GitHub party and talks about their login algorithm, being so sexy, right? Like that don't buy drinks. I've been to GitHub parties, they don't buy drinks. But you know what I mean? Like show off like how you got people to sign up for your app and drive cars for other people. That's pretty amazing.
Those Bay Area parties are a different breed, man.
Thankfully, I'm gladly a dad, loving that.
I mean, it was crazy because there were like two or three startups there, and they were all giving away free T-shirts because they had just raised a round, and the people were dancing on the table like extremely awkwardly. I can only imagine that it's gotten even crazier since then.
Yeah, we finished off some stuff back then for sure. We had good times.
Anyway, that's off topic.
Off topic. Just to close this off, guys, and just the last slide. So, it's okay to ask for feedback, during the whole like process, right? Like I said, these folks that are interviewing you, they already know the answer, right? And I think if you ask the right questions, like you might be able to pull it out of them, right? What it might be, right? Definitely, I'm not saying don't study all the things that you need to study, right? Like all those things are going to make you a good engineer, and like have the thirst, like drink from the water hose, go learn as many algorithms as you can. The point of tonight was to just give you the quick like flyover of like the most common ones that you'll ever see like actually being used at your job, and to like help you come in with the tools to say, like, in an interview, like, that sounds important, but it sounds like you need a mediator here, right? And be able to talk to that, because that's the things that like drive conversations between engineers as far as getting things done, right? What I say here, explaining what excites you is good, right? Like, definitely like talk about like why you're choosing that company and why like the things you're bringing to the table for them are the right choice, right? Like, people like to hear that. Unless what excites you is doing things that no one likes to do, like releases on Friday or production database debugging, or telling your CEO that he just lost $1 million in revenue because you were down for 12 seconds. Things like that you probably want to avoid. Asking lots of questions about the role and the growth, that's also important too. Like, just come in with like an attitude of just full thirst for, you know, the joy of coding and the passion for like solving what that business is faced with. And, you know, most businesses aren't going to tell you like all their internal woes in an interview, but, you know, if you can kind of snipe some of that out of the interview and talk to that and how your service to them and like the things you can provide will help solve that, then that'll stick in the interviewer's memory. Don't, though, tell them how their situation sounds really awful and that you're the answer to all their problems, right? So don't, you know, have confidence, but not an ego, right? There's a difference between the two. And the most important thing is just be the calm one. Just be relaxed. You know, you're in an interview, like it's just two professionals having a conversation, and like the best thing you can do is come away feeling like that, right? And so no, you're not gonna make them all. Like most of the interviews you go to, you aren't gonna get the job, and that's okay. Just keep trying, because someone will match up with you and say yes. And when that does, let us know, and we'll all cheer for you. All right. Any other questions? We're scheduled for an hour, and so I know we're a little over, but
I got another question. Sorry. So, I guess I'm looking about 6 months out from starting my job search post grad for my bachelor's degree, and so it's very daunting. But I have some time to prep. So, in that time, I know what I need to do, but in how to go about doing this type of prep, feel like I don't think there's anything on my GitHub. It's like I have one, but I haven't pushed anything because I'm just cracking my head against project assignments every day. And so would anybody recommend, or how to go about filling out your GitHub with these types of problems in things that interest you? Like for me, I love gaming, I love RPG, Warcraft, Final Fantasy, etc. So how to take the dryness out of, you know, leak code. Okay, do this algorithm. I'm like, well, that's not interesting to me. But like, hey, develop this binary tree that is about gaming, and that's fun. You know, I don't want to be necessarily, it would be great to be like a game dev and be writing C, but how to make it interesting to you so that, okay, I want to solve this problem because it's one, it's interesting, and two, also it's going to help me get the knowledge on the back end. So how to fill your portfolio and your work and your GitHub page with stuff that's interesting to you while tackling these types of problems.
Okay, so like let's take it. Okay. So this is my login. I'm not afraid to show it. Let's say here, we'll go to Unity. So like Unity. Sorry. Unity. Unity's not open source either. What's a tool?
Elements that are open source, but yeah.
Yeah. What's a tool in gaming? This is in my industry, so I'm not familiar with it, but what's a tool in gaming that would be like on GitHub that's pretty commonly found?
Pretty common.
Like, yeah, just name anything. Doesn't matter.
Trying to think of something that might have like a easily accessible repo here. It's not even necessarily going to be commonly used.
Yeah, that's okay.
You know what? I'll take the opportunity to promote our current
Okay, yeah.
project. Unity Tech. I'll throw the link in chat.
Oh, okay. This is the chat.
This is the project I'm working on.
Okay. Okay, so this is the perfect situation. Thanks. Okay, so here we have this project on GitHub, and like we know it's used in gaming or whatever, like, and maybe there's maybe I want to use it in a project I'm in or whatever, right? Or currently using it, whatever status is. But like here I am, I use this thing, or I'm like there's a bug in it. So guess what? I can come in and I can contribute to this, right? That's the simplest, quickest way to build out your GitHub, in my opinion, is to just be able to come in here and say like, okay, like what's some issues that they got here? Incorrect path variable for Windows Q to set up, here's a bug. Okay. And then just go investigate that and say, maybe it might be a red herring or whatever, but you know, like things that have labels, right? Like somebody must have put that label there, right? Like maybe like some other maybe not this repo, but like it's some other like more popular repos. You know, there may be some robots that come in and like triage bugs and say like, you know, valid issue or verified and things like that. So you know, things like that are helpful. But in my view, if you're where you're at in your journey and you feel like, you know, you're capable of just diving in on like some of these, maybe not this particular issue, but you know, an issue you kind of understand and you think you might be able to solve, then grab it and fix it for them and send a pull request. And those pull requests count against your little green dots on GitHub, even if they don't get closed.
Okay, so for this type of scenario, I mean, or just in general, like I've never gone really into other people's repos to look for bugs, but do you need to, like, is there some type of communication when like, okay, it's like, hey, I would like to help you. Do you want this help? And it's like,
yeah, you could comment. Yeah, absolutely.
Okay.
That would be a dream come true on GitHub if everyone did that, really. In some way, it might actually, in some other ways, it might be a lot of noise because everyone fixing it at the same time. But I mean, one of the things about GitHub that's cool about it being like sort of a social network for developers is that, you know, I mean, it's not uncommon. Like I have some repos where I've had two different developers give me two different solutions, and then you take the best of both of them, or one or the other. You know, it's not necessarily competition, right? It's really like about problem solving, and you know, that's how I kind of look at it. Yeah, it's just communication on these things. Like you have this area here, you can pick it up. So that's a good way to start. You know, also, you know, GitHub has GitHub pages, right? So as far as like your own personal website being hosted, like it's an excellent solution, easy to do that if you want to have like your portfolio put together up there. It's not. I don't. If you're going for like pure like backend engineering stuff, like I don't think that's like as important. I think if you're doing more like front end stuff, then like they kind of expect it. But you know, it's also just an easy way. Like as you're like, you know, if you're blogging about your journey, you know, it's an easy way to just get your GitHub like filled out like with contributions, right? Because you could just write your blog and, you know, commit that stuff and turns it green, and that counts. So that's why I see like developers that have like, you know, 8,000 contributions a year and stuff, and you're just like, my God, they're a truck. But truth is it's just that they got their blog on there and they're writing 2 posts a week.
do companies want to see like your problem solving? Do they want to see your code for these leak code type problems to where it's like, okay, you just want to publish? It's like, okay, so if I'm like working on my IDE at home and it's like, okay, this is what I did today and this is what I studied, this is what I learned, and now I know how to do this. And then, so do you want to go ahead and publish everything that you're doing, or do you just want to just keep it to yourself and keep it in the back of your brain house group?
I mean, in a lot of ways, I use GitHub for my brain house group. Honestly, like I have a ton of stuff up there, and some of it's relevant and some of it's not. And just from time to time, I go in there and I pull out little snippets of things that I've written in the past that are useful for my job now. So that's how I approach it personally. It's just kind of like, it's nice to be able to just kind of search it all and find stuff like that. And then probably not as well known a tool, but one that I like is Gist, is another one of their products. And I have a bunch of stuff up on here too, where, like I need to generate like what's called UUIDs and stuff, or just little functions and like helpers and stuff like that, little snippets of code I keep up here. So save all that stuff, because you'll find it time and time again as you're developing things. You're like, oh yeah, I have that, and in a pinch, it's helpful. Let's see if what a great suit. Like I just did this one, right? Little script I wrote just because I was frustrated that I couldn't just download all the stuff from S3. So I wrote a script to do it and mirror my S3 bucket. It is not in one. It is definitely not in one, but that's okay, right? So this is another good point though about interviews. Like if you do have a lot of this stuff like this, like you can maybe, if they are coming at you with like some crazy, binary search tree thing on a whiteboard, you can maybe try to shift the conversation and be like, well, hey, like, I put my GitHub on my resume. I can show you like something similar I did on there. And what's nice about that strategy is, the solution, right? You've taken a little bit of the power back, right? And you've got it where you understand this, and you're not answering the question they're coming in, blind to you trying to solve, right? If you have 6 months time, like it's a big ask, right? Like, I've had this stuff around for years and years. So, you can't build it all out like overnight, right? So don't try to, right? But, I think just when you're starting off, like, don't worry. I feel like a lot of coding camps are putting a lot of like pressure on people to like have a social presence as an engineer. But like, frankly, like one of the best engineers I know, like you can't find him on the internet. He's gone. He just like disappeared, and and that's just how it is, right? So the point being is that you can be a really great engineer and then never be on the internet ever again, and like, just do your work or whatever. And that's okay too. So I wouldn't stress out too much about like trying to get a bunch of code samples up on GitHub. But if you are interested in it, then I think it's a great start, because you can pick off issues, and like, frankly, like as a manager of like developers, like someone comes in there to me in an interview and says like, hey, I've been closing all these GitHub issues, I do like 1 or 2 a day, I'd be like, done, like come on board, right? Because that shows like some capability if you can do that, right? That's a lot of the job, I'm quite honest, is to be able to go in to some ticketing system and look at a problem and be like, okay, I think I can pick that one off and do it.
I think your suit looks great, Todd.
Oh, thanks. I could have picked a better tie though. We have any other questions?
We're a bit over, but I think if folks have more questions, Todd, you let me know when you need to cut it off.
Yeah, it's just conversational, so like I'm here for you guys. Yeah, I can link this if you want. You guys want to fork? Feel free to steal from me, and I don't mind. That's why it's up there. It's sharing.
Yep. Cool. Cool.
Cool.
Hey folks, thanks for coming. I'm gonna get the recording. Once this gets up to the cloud, I'll get it recorded and I'll get it posted in case you want to revisit anything. And if you have any follow-up questions, don't hesitate to post in the help channel. Anything else that's on your mind, and I look forward to seeing you next time. All right.
Appreciate it all. Thanks for coming.
We'll go. Thanks everybody.
Thank you.